Hello students, this is Varun. Till now we are done with operations on sets. Under the operations in sets, we have done union of sets, we have done intersection of sets. Then after we studied disjoint sets, we have discussed about the difference of two sets. And now the next concept is symmetric difference of two sets. If we have two sets, set A and set B, then what is the symmetric difference of these two sets? Well, the symmetric difference of two sets is denoted by this sign of triangle. A triangle B, it means A symmetric difference B. And it is given by A minus B union B minus A. That is difference of A and B union difference of sets B and A. And we already have discussed that A minus B and B minus A are not equal. Now let us try to understand the concept of symmetric difference with the help of one example. Let we have set A with the elements 1, 2, 3 and 4, and we have set B with the elements 3, 4, 7 and 9. To find the symmetric difference of set A and set B, first of all we have to find the difference of set A and B. And we know that difference of set A and B refers to those elements of set A which are not in B. You can see that 3 and 4 are those elements of set A which are also present in set B. So obviously the difference of A minus B will include only those elements of set A which are not in B, and they are 1 and 2. So the difference of set A and B is the set with the elements 1, 2. In the same way, the difference of sets B and A is the set with the elements 7 and 9. And now the symmetric difference of set A and set B is equals to set A minus B, means the set with the elements 1 and 2 union set B minus A, means the set with the elements 7 and 9. It means the symmetric difference of set A and set B equals to this set union this set. And union of these two sets is the set with the elements 1, 2, 7 and 9. Students, now our next thing is complement of a set. Let U be the universal set. And let A be any set such that A is subset of universal set. Then complement of set A is denoted by the sign A complement or A dash or U minus A. Since complement of a set A is equals to universal set minus set A, so it will include those elements of universal set which are not in A. Now let us take one example for this. Let set of natural numbers is the universal set. Universal set is set of natural numbers and A is a set of even numbers. Universal set is set of natural numbers and A is a set of even natural numbers. Then A complement equals to U minus A. It means A complement includes those elements of universal set which are not even. Since universal set is set of natural numbers has even natural numbers as well as odd natural numbers. And A complement is the set which contains only those elements of universal set which are not in A, and obviously they are the set of odd natural numbers. So that's why A complement is going to be set of odd natural numbers. Or we can understand this thing by if X belongs to set A, then X doesn't belongs to A complement and vice versa. Students, after this we are going to start with laws of algebra of sets. We have many laws, like we have commutative law, we have associative law, we have distributive laws, and we have many more laws. And for each law we have proof as well as we can verify these laws. Presently we are going to discuss about these laws only. We will not go for the proofs of these laws. In coming videos we will do their proofs as well. But now we are just going to discuss these laws. And students, under laws of algebra of sets, the first law is idempotent law. According to idempotent law, if A is a set, then A union A is equals to A, and set A intersection A is also equals to set A. Means the union of set A with itself is equals to set A only. In the same way, the intersection of set A with itself is again set A. This is what we call idempotent law. Next we have the identity laws. And we have two identity laws, and the first one is A union empty set, which is phi, is equals to set A, and the second one is A intersection universal set equals to set A. These two laws come under identity laws. Here phi is the identity element for union and universal set is identity for intersection. Next we have the commutative laws. Again we have two laws. One is for union and other is for intersection. If we have two sets A and B, then A union B equals to B union A. It means union is commutative. In the same way, set A intersection set B is equals to set B intersection set A. So union and intersection are commutative. In the same way, we have associative laws for three sets A, B and C, and again union and intersection both are associative. So for associative law, under union, A union bracket starts B union C is equals to A union B union C, which means whatsoever the way of grouping of set A, B and CB, the union of these three sets will always remain same irrespective of the pattern of their grouping. In the same way, A intersection B intersection C is equals to A intersection B intersection C. So we can say that both union and intersection are associative, which means union of three sets or intersection of three sets or any number of sets always remains same irrespective of the pattern of their grouping. Students, next we have distributive laws, and we have two distributive laws. And the first one is union over intersection. For three sets A, B and C, the distributive set of union over intersection states that A union B intersection C is equal to A union B intersection A union C. It is similar to the distributive property of multiplication under addition and subtraction, which we have done in the previous classes. Means A union B intersection C is equals to A union B intersection A union C. This is a distributive property of union over intersection. It is union over intersection because union is outside the bracket and intersection is inside the bracket. And if we have A intersection B union C. Then this is distributive law of intersection over union. And according to this, A intersection B union C is equals to A intersection B. Then after union, A intersection C. Next we have De Morgan's laws, and again we have two laws for this. First one is A union B. Set A union set B, the whole complement is equals to A complement intersection B complement. And the second law is set A intersection set B, the whole complement is equals to complement of set A union complement of set B. And this rule is what we call De Morgan's laws. First students, as I told you earlier that we have proofs for all these laws, and definitely we will do proofs in the coming videos. But for the time being, we will just go through these laws, and you can even verify these laws by taking an example of set A, set B or set C. But better if you take some simple and finite sets A, B and C for your convenience. Now after this, we have few more rules on operations on sets, like set A minus set B equals to A intersection B complement, and set B minus set A equals to B intersection set A the complement. Next is A minus B union set B is equal to set A union set B, and the difference of set A and B, that is A minus B intersection set B, equals to empty set, which is phi. Next, if set A is a subset of set B, then B complement is subset of A complement and vice versa. This is the sign of double implies. Means A is subset of B implies B complement is subset of A complement, and B complement subset of A complement implies A is subset of B. Then we have law of double complementation. Which states that A complement the complement equals to set A. Means if we take double complement of any set, we get that set only. Now we have laws of empty and universal sets, and these laws tells that complement of empty set is equals to universal set, and complement of universal set is equals to empty set, which is what we call phi. So students, these were some important laws regarding the sets and on their operations. There are some more properties on sets as well, which we'll do in the coming videos. You can verify all these laws by taking suitable examples or by using Venn diagrams. Again, Venn diagram is the way to show the relationship between two or more sets with the help of some diagrams. Again, we will do this Venn diagrams in coming videos. Thank you.